with that said, let's start doing checking to see how updating some of this data actually impacts the materialized view that we created. So this is why we added the trip IDs, so that we can get a single record here. And so again, this is the source OLTP taxi trips table that has about 7.2 million records. We'll copy this trip ID. I had previously, each time I recreate that table, obviously it's generating new UUID GUIDs. So I have to check this each time or change that. So what we're going to do is we're going to update that source table. We're just going to change this improvement surcharge by just increase it by 10% for one specific record. So we're going to do that. And then after that, we're going to run this the refresh command for the one row updated. So now we're going to run this refresh materialized view command. And like I said, this would be the same as if I were to go back to this job and just click start there, but we're going to do it this way. Okay, now that completed running, so that was the refresh after we updated that one record. So now if we go to look at the performance, and we can actually see it right here in this summary, bytes read 3.5 megs and bytes written 3.65 KB. And come on, there we go. And so what that tells us is that it only had to write a very small amount. That is probably just rewriting that one row. Now it does still read, have it listed as having read the 7.2 million. But if we look up here where it'll also list the percentage of the bytes that was pruned during the scanning and the percentage of the files that were pruned during the scanning. So we can see this, that it pruned 99% of the data. I think that this row's read sometimes, actually I think in both cases, I believe that they include some of the data that is written for the metadata that is used in the materialized views in order to do the incremental refreshes. So even though it says rows read is the same 7.2 million, the bytes read is only 3.5 megabytes, which is not the size of the table. So sometimes this is a little bit misleading to what the counts are. But as we can see, we updated one record and the bytes written was only that. And again, if we had recreated the whole table just to have that, because that one row got updated on our daily refresh, we would obviously be writing the entire table again. And so we can see that saves a lot of IO. And there's a really neat way that we can actually go ahead and we can look at this, and we can look at the history of how the materialized view has actually been updated, because it'll actually tell us. We can look at the event log table, and I did confirm, I did some Googling to make sure, even though the event type that it has us looking at is planning information, that is in fact what is actually used. So I guess it doesn't show up in this table until it's actually completed. So don't be misled by the fact it just says planning. It's not like a query plan where it's a possible thing. It's what's actually happened. But anyway, so we can see these first two were complete recomputes. This is because I think I ran the create statement, create refresh, I think because I ran it twice, or I ran it once, I think before I had done the done the row tracking, and then once after, so it rebuilt it. But either way, this is the one that just happened based on updating that one row, and we can see that it says it was row based. If we were to Google, we would see there's a list of different kinds of updates that it would be listed in this message table, depending on how the optimizer decides what to do. And we'll see a few of those other options or those other attributes as we continue on here. So let's see. So here, what we're going to try to do is we are going to, let's see here, we want to do the vendor IDs here, which again, we did the, which is what we did the partition on it by. There's only 2 in there plus 50,000 blank ones, which were null that we're not going to worry about. So this time, let's update a larger slice of the data. Instead of 1 record, let's do about, it's about a third of it, because we're going to do where vendor ID equals to 1. So let's run that again. We're updating the underlying table there. So I'm going to let that run. Once that's done, then oh, there we go. So it updated 2.48 million records, and now we will run this this again to refresh the materialized view. And now that we've refreshed the materialized view after having updated about a third of the records based on the vendor ID, if we go here and look at the performance for this, if we pull this up, see now this is, as I was saying, this is where the rose red gets a little bit confusing, and I'm not going to dive down into why this is what it is. But because it says rose red 21 million, and now the table itself only has 7.2 million rows in it. So I think that this, again, I think this has to do with some of the reading some of the metadata record that it has, or maybe if it has to do a shuffle and move the data, it's reading the rows twice, etc. But that's for another demo. But we do see that it, again, it pruned a lot of the data during the scan. It pruned a lot of the files, and it does say that it wrote 7.2 million records, which is a little unexpected because it updated only 2.4. But again, that could have to do with what it did for some of the metadata updates and whatever. So, and again, the bytes written, again, it's a little higher than we would expect. But the optimizer decided that, actually, wait, let's check. I'm pretty sure that it again did the row-based and not a full. Let's take a look here. Yes, see, so it did again do a row-based, and because that was what it just the optimizer decided would be the most efficient. So let's see here. The next one we want to try to do is we'll do this one real quick. We'll do an update based on these dates. And so what we're going to do is this is going to update a handful of records, I believe. Yeah, so we updated 28 records based on the date and just set it to another random date. And if we again refresh the materialized view, okay, and that's that completed. So now if we take a look here again, since it only updated 20 records, we see it only wrote almost just about 6K, pruned 99% of what it had to read. It did, again, it says that it read 7 million rows, but it was able to prune 300 megs of that and only wrote what it had to do. Again, if we were recreating the table, we would obviously be deleting and reloading 7 million records. So, and if we look at this guy again, we should see, I believe it's going to just be another row-based, yep, another row-based update. So for our next trick, let's try to insert records into the taxi trips table. So remember, in the beginning, we had actually pulled over 3 files from the taxi trips data. So these are just 2 more months, November and December. And we're just doing again, we're just creating a UUID as the trip ID, union all. We want to load all of them in. So let's go ahead and we do that. And after running that insert statement for those 2 extra files, we've inserted another 13 million or 13.7 million records. And I had actually also gone ahead and I ran this the Materialized View refresh. And if we look at the performance for that, and we go ahead and we look at this, rows written is only 13,000, or I'm sorry, 13 million, because it knew that it didn't have to do anything else with the table. It was able to just do an append. So I'm not really sure what it is thinking about that it pruned here, but bottom line is it only wrote what had to be written. And if we go to take a look at the planning information again, we will see another type here. We will see append-only. So again, it only wrote what needed to be written. It did not recreate the entire table. And we're going to do one more thing here. We're going to see if we can get it to force the optimizer to do a complete recompute. We're going to see what happens, because when I've done this a couple times when I was doing my walkthrough for this demo, one time it did a complete recompute and another time it did not, and still did it as a row based. So I'm not sure what else the elves are doing underneath to decide which way the optimizer might go, but let's give it a try and see what happens. So if we'll run this update, what I'm doing here is, this is just completely random. I'm just updating the vendor ID, adding 10 to it. The idea just being that the partition by column is going to be changed for every single record in that table. So we'll run that update, and then I will also run this refresh. Okay, so we updated 20 million records. And then if we take a look here, we reran we did the refresh, and let's see what it did here. So okay, it read 105 million records. Again, we're assuming that has something to do with some of the metadata that it's reading. Or actually, it could have to also do, if it's doing an update, it could be doing a delete and then doing an insert and considering that as two separate rows. But it wrote the number of records that were updated. And now if we take a look at this to see the planning information, let's see if it did a recompute or if it did. Okay, so yeah, so it went ahead and it did a row based again. And this is something that I will touch on briefly right now, and then, but it definitely would be for a part 2 because I have more to learn. But if we go ahead and we look at, so previously I was only looking at the message column that has the row-based append or complete recompute, but there's actually a lot more information in here. If we look at, here it is, if we look at the details, there's a bunch of JSON information in here that has to do with how the optimizer, the cost optimizer, came to the conclusion that it did. And so we will just take a very quick look here. And I looked at this previously, but here's the new one. Drop that JSON into Notepad++, and just our handy JSON viewer here, and do a format. Zoom in a little bit here. And so this is, like I said, this is just a touch of what else we could get into here. But so the information here is about the different techniques or whatever that it could use. And so we can see here that the maintenance type of complete recompute is chosen, is false, is applicable, is true, means it would be possible. And the cost, and I have no idea what metric this is of, but it has a cost listed of 31, whatever that is. And then we have maintenance type of row-based. It says, is applicable, true, it can be row-based, is chosen, true. But then we have this number here, which is, let's see, 3, 6, 9, 10 digits, and double check, 3, 6, 9, 10 digits. So so this appears to have a cost that is twice as large, but it's still, the optimizer still decided to go with the row-based update. And again, when I did a little bit of Googling about that, it has to do with how much weight Databricks puts on doing a row-based update versus, I guess, actually recreating the entire table, because of how then that might impact other downstream things. So with that, we hopefully have learned a better way to architect loading downstream tables that have calculations to them without having to do a complete truncate and reload of a table. And we can just do things incrementally and allow Databricks and its optimizer to handle any of the cost and judgment and change detection on its own. So thank you, and we'll talk again next time.